In the last class, we have gone through the one exercise that is on command line arguments. Is this okay? We have gone through the command line arguments, right? Is this okay? I want to interact with the people, right? Anushka, you can regularly respond back to me. You can unmute and talk to me.
Okay, sir.
Regularly, you please talk to me, right? Whenever I ask question, you will be responding. Rest all people will keep in you. So this is the program which we have gone through. When you run this, okay, you get an output something like this, right? In this case, when I have given 4 arguments, it will display the 5 arguments here because of the first argument is the name of the file itself. This is what we have gone through, right? So we will run this and check it, and then we'll try to extend this today, right? I'll compile cc minus o, right? Then name of the argument, name of the executable file, I'll give a same as the C program name, cmd line arguments, right? This is the executable file name. Then source file name is C some command line mens.c. When I compile this, right now executable file is available. Name of the executable file is, this is the serial number for you in my repository. And look at that. By mistake, I have given C okay as a capital. Right? I need to give a C as a capital. Right? CMD line arguments. Now I'll give arguments X, Y, Z. Right? So now look at that. When I have given 3 arguments, it will display the ARGC value is 4, and the first argument is the name of the file itself. Then remaining 3 arguments, actual whatever I have passed, it will display. So this is what we have done in the last class. All of you, did you try this one? Anushka?
What?
Did you try this program which we have discussed in the last class?
Yes, sir.
Okay. So I assume that all of you have tried this. Now what I'll do is, I will extend this one and introduce one system call. Right? All of you please do this exercise in okay as a laboratory exercise. Now let's get into next one. I'll show the another one. See here. Here I'll introduce what is called as the system called EXECL. Right? Using this, there are many variations of this. Using this, you can run the another program from this program. What is that? Is the name of this program is 7 executable exec command line. Now through that, what I do is I will run the program which just now we compiled and created executable file. And through the program, I'll pass command line arguments, right? Ramu, Umakant, Ramakant, Lakshmikant, and it ends with null character. The null character is represented, okay, it is a type conversion 0, right? You convert that into a character null, right, and you represent it. Right? It ends with a null character. So, the command line, the executable file which you are going to execute is this. Right? And its complete path you have to provide. Right? How to get a complete path of a given file? Simply press PWD, print working directory. Right? So you will get this particular, okay, this is the complete path of this particular directory. Are you getting this? Right? And inside this, you have a file command line arguments as executable, and that will be executing. Right? Is it okay? What is that we are doing here? Have you understood it? Anushka, I wanted you people to discuss with me.
Excuse me, sir.
Please.
Sir, are we trying to execute another program with some program, sir?
Yes, yes.
One program with another.
Yeah,
Sir, so which program is executing which one, sir?
yeah. Now, whatever I am showing,
Sir,
1 minute, whatever I am showing, right, it is 7, serial number 7. You can see my cursor.
yeah, sir.
The name of this program where you are seeing on the screen is 7-exec. 1 minute, I will switch on power supply. Yeah, the name of the program which you are seeing on the screen is 7exec In that, I am executing 5-cmd line arguments, command line arguments. 5. File name beginning with a 5. Look at the cursor.
Yeah, sir, yeah.
Right. Is that clear?
Yes, sir.
Any question from anybody? So when you run the under program, which you are seeing here with a complete path, it ends with the name of the file which you want to run, comma, all the command line arguments you pass it here, it ends with a null character. So when you execute that one, right, the new program will come and sit in the memory occupied by this program. This program in the sense 7-exec. So 7-exec is no longer available in the memory the moment the highlighted line is executed. So immediately next line, whatever I'm showing here, this line is not executed at all because it is no longer available in the memory. Is that clear?
Sir, can you repeat that?
So look at that. Whatever the highlighted program you are seeing, this it is called 7-exec cmd line.c. Right? When I run this, it is getting stored in the memory and then being executed by the CPU. But what is this 7-exec command line program is doing? It is making an attempt to run another program. When another program is run, right, the 7-exec cmd line, whatever there in the memory, is removed and the new program 5-cmd line arguments is being put into that. So when it is removed, this line is no longer available. That's why the message, this line is not executed at all.
So, sir, when the new program will run, the old program will automatically be off.
Old program is no longer there in the memory at all. It is dead,
Okay, sir.
right? That's why I
Okay,
written. So this printf will not appear on the screen. Are you okay?
sir, got that, sir.
Shall we run the program and see?
Yes, sir.
Okay. Now look at that. There are two programs here. In short, I refer, okay, program number 5. Look at that point. This is called program number 5, right? And refer the cursor here. This is a program number 7. The program number 7, entire thing is this. Highlighted one is program number 7. Call it. Okay? Are you okay? I want a response.
Yes, sir, yes, sir.
Right. Now, let's look into that. Program number 5 and program number 7. This is how I'll refer. So let's look into that. I'll compile the program number 5. CC minus O, which already we have done it. CMD, sorry, minus O, that is 5 dash CMD line arguments, then 5 dash CMD line arguments dot C. Okay, what is that? What will happen? CMD line 5, CMD line arguments. 1 minute. The arguments.c. So now 5 dash command line arguments exe file is available. I will not run as it is, right? I will take another program cc. I will not use minus o. Let a dot out be there. 7 dash command line arguments dot c. I'll compile it. Right? What is this? Okay, why it is not there? Sorry, it is not 7 command line arguments. It is exec. exec cmd command line. That's all. Dot c. Right? So what is this?
C is capital, sir, in CMD, sir.
Right. Yeah, you are right. You are right. You are right. Right? Right? This is okay? Right. Now A dot out is generated for this program. This, now look at that A dot out. So A dot out from this, it's the 7th program. From this 5th program I am running. Okay? So when I run A dot out, the 5th program is run and it is showing this. For the 5th program, okay, for the 5th program, 7th program is giving all command line arguments which you will see here. 5th program is run by, right, 7th program where command line arguments are this. Are you clear? Are you clear?
Sir, so sir, do we have to compile the fifth program first, then we have to compile the 7th program?
Exactly. That's what I've shown. That executable you have to keep it ready because what you are telling is 5th program I want to run. That means 5th program should be ready there.
Okay, sir.
Clear? Okay?
Sir, can I ask one thing, sir? So, sir, what is the use of XXCL, sir? Because, sir, the next line after the XXCL is not, sir, is not executing, and we are just executing another program with this program. So, what is the use of using XXCL, sir?
Okay, now look at that. Many times it may so happen that, okay, what is the use of that? Probably you have to wait for another week to get the answer. The reason here I'll tell you, right? When you create a child process, which I have not told you yet, using this, we will be creating the process, right? One process will execute another process. And we call relationship as a parent and child. The parent and child, when they execute, okay, the another thing, child can execute another program and remove it itself from the memory. The purpose of that program is to run another program. In that situation, you will go for execl. Are you clear?
So, like in C, na, sir, we call a function, and after the work of the function is completed, the next line is executed, sir.
See what happens here.
Yes,
Okay, I'll tell
yes,
you. In this case, when execl is called, the purpose of this is to run one program from another program. The purpose of this is to run another program. The purpose of this is to run another program which you don't know. Which is that program? Program itself knows. For example, right, a dot out. I know only a dot out. Which program it will run, I don't know. But it's built in that the purpose of this a dot out is to run another program. It may be some business. It does certain business and afterwards call that and terminate itself. Are you clear?
okay.
Right. In operating system, what happens? Right. Probably you might have got introduced to operating system kernel. We talk about the kernel. Am I right? Kernel has been referred by your teacher. Kernel.
Yes, sir. Yes, sir.
Right.
Yes, sir. Yes, sir.
Right. Here, when you run this program a dot out, who will execute it? Kernel. Am I right?
Yes, sir.
Kernel, how does it execute the a dot out? By calling execl only. Though you are typing here a dot out, Though operating system executed, how does operating system execute this a dot out?
Through kernel.
Kernel. What part of kernel execute this a dot out?
I don't know that much details. Maybe compiler, sir.
Right. Okay, that's what we say. Right, kernel. Okay, no, wait 1 minute. Okay, let me take you to the another situation. Let me take you to the another situation where people are waiting. Please wait. Right, 1 minute. I'll take you to the my PowerPoint presentation and I'll let you know. Please wait. 1 minute. You have to wait for that.
Okay.
1 minute. One minute. You will see this. You will understand. You will appreciate this. When the time gets over, no, again you will be connecting to this until I complete another two programs which are very small. Yeah, see here, I'll show you. Right. So this is how C program executes. Okay. In C program, you have got main function. Do you know? Yeah. That main function is here. Right. Main functions calls your user defined functions and return. Right. Right. So who will, when you run your program a dot out, who will call the main function? Who will call? Right? There is something called C startup routine provided by compiler.
Okay.
Right. C startup routine. Who will call this C startup routine? Kernel exec. Kernel exec will call C startup routine, and C startup routine, it will make all your command line arguments ready. C startup routine will provide command line arguments to your main function, and hence your program executes it. Are you clear?
Somewhat, sir. Yes, sir.
Now it takes some time, right? As and when you proceed, right? Don't expect that everything in one shot you come to know about that, because there are a lot of assumptions you have to do.
Yeah.
Yeah. Okay. Now you know when you are running a dot out, am I right? At dollar prompt, please see here. At dollar prompt, you write a dot out. Am I right?
Yes, sir.
You dot a dot out. Who will run the main function of a dot out? Main function of the a dot out. Who will run? Who will call? You don't know. Am I right?
I don't know. Yes, sir.
Okay. Expecting that you knowing that one is also not right here. Right? So who will call? In the sense, there is something called C startup routine here. C startup routine will call the main of a dot out. And then actually your program will start executing it. Right?
Fine, sir.
Right.
Fine.
Yeah. It is something like God, I'm telling. When I say this is God, you have to believe it and go.
Okay, sir.
Right. But who will call C startup routine? Kernel will call.
Kernel, sir. Yes, sir.
How kernel will call that one? Exec. Exec. Exec a dot out. It executes. Got it?
Okay. Yes, sir. Yes, sir.
So this particular aspect, we are doing it in the laboratory and checking it. Now, okay, one program is here. The other program is here. I want to, from one program, execute another program. How do I do?
XXC.
Yes, that's what we are learning here. Right? Is that okay?
Sir.
Somewhat. Right?
Yeah. Yes.
Yeah, that is the right word. Okay, because first time everything will be somewhat. Got it?
Yes.
Right.
Thank you, sir.
Now look into that. Right? I want to run fifth program. From which program? Seventh program. This entire thing, seventh program. When you call execl, the feature is that it will execute this. this entire new program will come and sit where 7th program is running, so that subsequently whatever that is there, they are no longer available. Got it? And that's what you are seeing it here. The 7th program is A dot out, because I'm not given any name for command line and not given any name for executable. So A dot out. This A dot out, when I run, okay, the 5th program will run. Why? Because you are called here. And that is the use of EXEL. You want to know more details of EXECL? Hello? Hello, you want to know more about EXECL?
Yes, sir.
Yeah, for that you have a manual in Linux. Man, whatever the command you want to write, you want to know, type it. EXECL. Man stands for manual. The ready manual is available in Unix environment. You can browse. See, what is that? The EXECL, EXEC or variation of this family of function replaces the current process image with the new process image. What is the process? Did SMUC tell about what is the process? Hello? Hello? Do
A
you know what is,
sequential set of instructions.
do you know about the process? What is the process?
A set of instructions, you can say.
Yeah. Set of instruction is called program. When a program is
Okay.
executed, okay, as an instruction, it is called a process.
Yes.
So one process is replaced by another process. Which process is being replaced by other process? Process number 7 is being replaced by process number 5. Is that okay? Is that okay?
Yes, sir.
Yeah. Now take a screenshot of this. Right? Take a screenshot. Okay. The program number 5, already you know it. Take a screenshot, all of you, because it's a small program. All of you, all participant, take a screenshot. I'll send these things in your WhatsApp group. This is program number 5. Taken? Hello?
Taken, sir.
Taken.
Yeah. This program is to be compiled. Create executable file whose name is 5cmd line arguments dot arguments. This is a executable name. Then 7th program. Okay, take a screenshot now. From this program, you are running the previous program. Anyhow, I'll send this in your WhatsApp group in the evening. Meanwhile, you can try. Okay? Yes or no?
Yes, sir.
Sir, someone.
Okay, ask
Sir,
question.
unlock the meeting, sir.
Hello?
Yes, sir. Unlock the meeting, sir. Someone is waiting outside.
Okay, 1 minute. 1 minute. Nobody is waiting now here. It is not showing anybody waiting here.
Sir, someone is messaging me.
Okay, now any question here? Otherwise, I'll go to the next program.
Sir, the header file unistd.h, sir. It's for EXECL, sir.
Yes, how to know it, right? How to know it, which one to use. See here, okay, it is given here, synopsis, manual. For all this command, right, system call, which header file to be used, it is given here, that you have to include there. Yes?
Yes, sir.
Any question? The floor is open for discussion. So this exercise is use of EXECL. Shall I go to next program? Shall I go to next program?
Sir.
Yes, sir.
Okay. Now look at that. Take a screenshot of this first. Take a screenshot of this. Taken?
Yes, sir. Taken.
Okay. Now look at that. Assume that you are all processes. You have been given a unique ID, no? By university. What is that called? What is that called?
SN.
USN number. So when the programs are running in operating system, the operating system will assign a unique ID. We call it as a process ID. We call it as a process ID. Just 1 minute. We call it as a process ID. Is that clear? Is that clear?
Yes, sir. Yes, sir. Yes, sir.
How to get a process ID? Say, Anushka, what is your USN number?
Sir, 2ST 19CS022.
22022, right? I asked you, you informed me. But in operating system, how to write a program to know the process ID of this program only, right? For that, we use a system call called getPID. GetPID you call, it is stored in the variable called PID, which is of the type int or long int, whatever it is there, right? Then process ID is okay, percentage, okay, LD, ID, or ID, whatever it is, right? Then PID. So when you run it, the process ID is being displayed. And please remember, every time the program is run, the different ID is given. It is not same all the time. But as long as it is running, it is unique. The moment it stops running, okay, that ID is no longer valid. Validity will expire the moment the program terminates. Clear? Shall we run this program and see?
Yes, sir.
Shall we run this program? Okay, now look at that. Okay, CC, right? 34 PROCESS ID, capital ID, it seems. Capital ID, hope so. Is it capital ID? No. 34. 1 minute. CC, right? 34 process ID dot C.
दे दो मम्मी को.
Okay, look into that. CC34 process ID dot C. Now A dot out I'm running. A dot out. A dot out is a program. When it runs, it becomes a process. What is the USN number of this A dot out? That I'm going to display. Look into that. 33497. Is that clear? Is that clear?
Sir.
Hmm?
Yes, sir.
But which program? Oh, the current program only.
A dot out, that program itself. I want to know USN number of myself. Get my PID. Okay?
Yes.
Is that clear?
Yes, sir. Yes, sir.
Now look at that. Every process has a parent. Am I right? Every process has a parent. Okay? Now look at that. A dot out. I'm running. Okay? Who is the parent of A dot out? Who is the parent of A dot out? A dot out.
System subroutines.
Yeah. In a system, there are many processes available. So this dollar prompt, whatever you get, we call it a shell prompt. Shell is a command line interface. This command line interface, again, that is a program which will take your A dot out and it will call exec and run it and give a result back to you. It is an interface. Okay, a shell is an interface between You and the system. Am I right? Is it okay?
Yes, sir.
Right.
Please repeat.
So the shell, whatever the shell, the dollar prompt you see, there is a shell running. The shell is showing all these things. Whatever the command you give, right, you are giving instruction to the shell. There is a program called shell, which will take whatever the command you type, here a dot out, passes it to kernel, right? And that shell is a parent for your a dot out. Do you agree? Yes or no? Anushka, USA number
Yes, sir.
22. Hello?
Yes, sir.
Just to, with the permission of Anushka, I'll tell. Now, the Anushka's USA number is 22. Her father's USA number could be like 500, you take it. So when Anushka calls get PID, it is 22. When she calls tell my parents' ID, it is a 500. That is now you understood? Understood or not? Yes?
So, so the please repeat.
Yes or no?
Sir, the parent process I can't get it, sir.
Which one?
The parent process, sir.
Okay, 1 minute. Okay, let me use some tool to write it on the screen and tell you. See, okay, here is the environment, right? And this is called it as a dollar. And this is what I call as a shell, right? Shell, right? Consider that its USA number is 500, right? It's a USA number is 500. Within that, what you are doing is you are a dot out, you are running, right? A dot out. What is the a dot out? Is PID number, process ID number. Say call it as a 400, right? So process ID of a dot out is 400. It's a parent. Okay, ID is 500. Do you agree? Agree? Yes or no? Anushka.
Yes, sir. Yeah.
Right. So who is a parent? Parent is a shell script, shell, which has provided you the dollar prompt. So your a dot out, when you run it, it takes this one and it uses exec, which you already seen, and it runs your a dot out. Are you clear? Hmm?
Yes, sir.
Right. So now let's see that every process has a parent, right? Every process has a parent. So every process that you run, program you run at a command prompt, shell is its parent. Shell is nothing but command line interface between you and kernel. Shall I run the program and show? Shall I run the program and show?
Yes, sir. Yes, sir.
Yeah, look into this. Now, I'll show the other program. Take a screenshot of this. For this program, to know its parent, its ID, it is a get PID. To know its parent ID, it is a get PID. Get parent PID. Take a screenshot. Is it okay?
Taken,
Yes, sir.
Anushka, is it okay? Shall I run this? Anushka,
Sir,
yeah. See here now. CC 36 here. 36 process ID dot C. Now I'll run it. A dot out. A dot out, okay, is a child, and dollar prompt, whatever the program is giving, that is running. It is called shell. Okay, okay, its ID is different. By default, it is a part of the system program given by the operating system. Without that, you cannot use operating system at all. So when I run this, look, process ID of the A dot out is 3523, right? Then parent process ID is 3354. Am I right? Yes or no?
yes, sir.
Yes, sir.
But how to know that what are the process running in the system? For that, PS minus E, PS command. Now we'll search for 3354. What is that? Now search 3354. It is there. There are many processes are running in the background. They are called daemon process. For example, right? For example, for the human body, we say pancha prana, right? Breathing is one, blood circulation is another, vomiting is a third one, right? All that, this, okay, it is happening, okay, without your knowledge. All that we call the background process for the human body. Similarly, now look at that here. 3354 is a bash. Bash is the shell that is running. Within that, you are executing all commands. Is that clear?
Sir.
Yes?
Yes, sir.
Yeah. But now I want to know, okay, this program has terminated immediately. This program has terminated immediately, right? But I don't want to terminate this immediately and know my ID also, running or not. So what I do is while true, don't do anything. So what is that I'm doing? Infinite loop. I'll run this in the infinite loop. See here. See, what is this? 36 process ID dot C. Hey, what has happened? CC 36 process ID dot C. Right. Now I'll run A dot out. It will go in the infinite loop. It doesn't come out of that. No, it is in the infinite loop. That means child has not terminated. I mean, this program has not terminated. So now I will see 3542 and 3354 both are being listed. I'll open another terminal. One minute. Just 1 minute. I'll open terminal. Here. Yeah. Then here, this terminal is different. That terminal is different. PS minus E, I'll do it. Now here, see, right? I'll open both the things, right? Where left hand side is in the infinite loop, 3542 is my program running. 3542, whether it is there or not, 3542. Look at that, A dot out. Can you figure out this? Can you figure out this? All of you, Anushka, can you see the arrow mark? Cursor here?
Yes, sir.
Yes? Anushka?
Where, sir?
Now, this is my program A dot out. Its parent is bash, that is shell. Okay, what is that? 3354, right? 3354, 3354, 3354 bash. Can you see here?
Yes, sir.
Okay, now I'll come back here. So, this is every process has an ID and every process has its parent. I'll press Ctrl C to terminate. Clear? So this is another program, okay, through which you can get a parent process ID and parent process ID. So take a screenshot of this. Is that clear?
What was the use of using a while loop, sir?
Hey, it is just to do experiment, to get into infinite loop so that I can get into other terminal and check that this program ID I can get it. Otherwise, it will terminate immediately. I will not get its ID at all in when I list all the process live. Okay,
Yes, sir. Yes, sir.
for that reason. So now session is getting terminated. So both all of you tried all these three programs today, right? Next week we will get into fork and vfork, how to create a process itself, right? Is that clear?
Yes, sir.
Right.
Yes, sir. Clear.
Right. If any question or any doubt is there, all CRs, you collect all the things and arrange one more session on Monday or Sunday, whatever that is there, we will do it. Right? Thank you for joining after the lunch. Very difficult time.
Thank you, sir.
Thank you so much, sir.
True, true. Okay, look at that. Anushka telling true. You are correct. Right? Good. Right? Please go through that one. I will close this session. Right. As many as
Thank you.
50 students have participated, ask all other people to join whenever we take. And I'll make this video available to you. Okay, wait for that. Right? Shall I end the program? Shall I end the meeting?
Yes, sir.
Okay, thank you. Bye.
Thank you.
All
Thank you.
these three programs today. Bye.
Okay,
Bye.
sir.